Okay, so let me kind of explain what I hope to do in this video, and then we'll go ahead and jump into it. CLS 3302 can be a very challenging class, and in fact I think of all the courses I teach at Weber State, it is the one that is the most challenging. And for a long time I tried to approach general questions and topics by referring to study guides or the presentations or answering questions on a kind of a as they come in sort of basis. What I'm hoping to do with this video is kind of explain some of the basic concepts so that everyone can have the same basis for what we're going to be doing this semester. The reasoning behind this, I think these few basic concepts are really hard to wrap your brain around, so I hope that this video helps with some of that. Sorry about the nasally voice, sorry about the format, sorry that I'll be scribbling here in front of you and that, things kind of seem herky-gurky. If you want a real professional quality video, you've come to the wrong place. So, anyway, I'm going to start with the idea of accuracy and precision, because this kind of lies at the heart of everything that we are going for. Not everything, but, they're huge concepts. So, accuracy. So when I think of accuracy, and you'll see this example all over the place, but if you think of playing darts, accuracy would be hitting the bullseye. Yeah, I know the triple 20 is worth more than the 50-point bullseye, but accuracy is basically the distance from the target. So if my target looks like this, with the bullseye in the middle, accurate would be hitting right on that bullseye. Does that make sense? So then we have the idea of precision, which is a little bit different. Precision then, instead of being the distance that I am away from the target, what we're looking at with precision is the distance that each dart or value, if we're talking about lab work, precision is the distance each one of those points is from another point. So a test, or someone who throws darts who's very precise, is going to have all their points relatively close together. So it obviously goes without saying that what we're looking for in the lab is not just accurate, and definitely not just precise, but what we want precise and accurate, or we want all of our values to be huddled around that value that we should be getting without a whole lot of deviation. So what we're looking to make sure in the lab is that our instruments are running accurately, that they are precise, and that they're comparable to what we've already got going for us. Or if we're bringing in a new instrument, we need to be able to prove that it is as good as the previous instrument. And what we're trying to prove is that it is both precise and accurate. So we can't really just eyeball these things. We need some way of assessing or predicting or evaluating this accuracy or precision. So that's where the idea of inferring comes in. So you'll hear a lot about inferential statistics. And what we're trying to do with inferential statistics is we're using data or information to draw ideas or conclusions about something. My family makes fun of me because I seem to go through cars very quickly. Every couple of years I'm buying a new car. And I always buy used cars, and I have found that over time there are certain cars I like better than others. I'll come right out and say I've owned several Hondas. The reason I keep buying Hondas is because my experiences in the past have shown me that Hondas are very reliable and that I get a lot out of what I put into these cars. The same sort of thing goes into statistics. If I've got a lot of different values that are telling me something, I can draw conclusions from that. The problem is what we're doing is we're working with a lot of numbers, and it becomes very difficult to assign what sort of conclusions we can draw just given these random sets of numbers. So that's where statistics come in. They bridge the gap between all this data, these information, or these data points, and what we can actually draw from that. So basically what we're trying to do is collect data and then make guesses as to what sort of conclusions we can draw. So these guesses are what you have probably already seen we refer to as hypotheses, or a hypothesis. So in CLS 3302, as is the case with most statistics, we have an alternative and a null hypothesis. The alternative is often abbreviated HA and the null HO. So, for a very long time, this whole idea of a null and an alternative hypothesis really kind of boggled my mind. I couldn't understand it. And I'm going to explain to you the way I understand it, and I hope it doesn't screw with what you've already put into your brain. When I think of null, or I think of the zero that goes along with that H, I think like zip, zero, nada, null. So all of these words basically mean none, nothing. Or in our case, what we usually equate this to is we will say no difference. Or even better, no statistically significant difference. So what the null alternative is saying to us is that there is no difference from one thing to the next. So I might say that there's a difference in intelligence between people who drive Hondas and people who drive something else. So my null hypothesis would say there is no difference in intelligence between people who drive Hondas and those who don't. My alternative then is going to be essentially the opposite. Or for this case, I would say there is a statistically significant difference between people, or in intelligence, between people who drive Hondas and those who don't. So that's the difference, or that's where we create these null and alternative hypotheses. The weird thing that I think is sometimes counterintuitive is that we're not trying to prove our hypothesis. Rather, we say it in kind of a way that gets us out of maybe coming right out and being like, hey, I've proven that Honda drivers are smarter. What we do in statistics is we work with this null. And what we're working to do is either accept it and say, hey, there really is no statistically significant difference here, or we're going to reject it. So by rejecting the null, we say, you know what, this null says that there is no difference. I'm rejecting that. I'm seeing some sort of difference here, and it's significant.